Let's practice some graphing. HK. I'm going to start by locating HK. I'll go up one amplitude, down one amplitude, then I'll go across by one period. It's 2 pi. Sine starts in the middle. Let me cut up my period into quarters. Sine starts in the middle, goes high, goes middle, goes low, goes middle. So I'll locate HK. I'll go up one amplitude, down one amplitude. I'll locate the end of the period, 2 pi, half, quarters, draw my box. And it's cosine, which normally starts high, but it's flipped. Starts low, middle, upper, middle, bottom. Right, because this is plus 0. So the 1 is on the outside, the 0 is on the inside. I'll locate HK, 0, 1. Go up an amplitude, down an amplitude. I'll go over by a period. Half, quarters. Sine starts in the middle, goes high, middle, low, high. There's a 2 pi period. It's flipped cosine, so it's going to start low instead of high. Oh, I forgot to quarter my period, half, and then quarters. Low, middle, high. started from 0, the period would be 2 pi would end there. But since I'm starting quarter pi backwards, I'll just go back here and I'll go backwards quarter pi, and I know that must be 2 pi. Otherwise, I could just do it with fractions and see. Where do you end up if you start at negative pi over 4 and you move to the right by 2 pi? One, two, three, 4, 5, 6, 7 pi over 4. I'll keep making my box. And then I need to, there's half, and then quarters. It's cosine and it's flipped, so it'll start at the bottom, middle. It's just the regular parent cosine function flipped. Halves, quarters. I almost wrote it high there. I'll go through the middle. Starting at pi 0. And my period is 2 pi. It takes me off the thing. Up a period, down a period. Oops. Halves, quarters. And it's upside down. Cosine starts low, middle, high, middle, low. I'll have to change my scale again. So 8. See, it's like I can go 1, 2, 3, 4, 5, 6, 7, 8. Start at HK. Up in amplitude, down in amplitude. To the right by a period. Cut it in half, cut it in quarters. Sine function starts middle, high, middle, low. I made a mistake on this one. I had to redo it. So I think I should made a few mistakes doing this. It's convincing me that I should check my answers more often. So I'm going to do that. So the coordinates of this point are 2, 1. So I'm plugging 2 in for x. Pi over 2 is 90 degrees. It's right there. So sine is positive 1 equals 1, and that checks out. period. And then it is upside down cosine, so it starts slow. Oh, I forgot to do my quarter intervals. Half, quarters. Upside down cosine, low, middle. Looks good. I could check this. I could, I haven't done that with any of these other ones yet. But if I was unsure, I could plug in any of these points. I think maybe the peaks are safer to plug in. So I won't plug in the x-axis, the x-intercepts. So I'll just choose this one. 3 pi over 4, I'm a 1. So I'll take this number and I'll plug it in there. I get -4 cosine. I'll just add those in my head. 3/4 pi, quarter pi, a whole pi. And this is in this case an easy unit circle position. You're supposed to know all these points, but when you plug in a x-intercept or a peak or a valley, it won't be one of these positions. It'll be one of the axis positions on the unit circle. So it'll be 0, 1, or -1. Let's see, pi is there. Cosine is the x coordinate, -1. -4 times -1 is +4. So it looks like I made a mistake. So what happened? I didn't apply my my amplitude, so I didn't draw my box right. So I gotta go up 4, down 4. I already know I'm gonna flip and multiply that, so I'm just gonna go ahead and flip it. 3 over 2 pi. Look, I've made another mistake. My amplitude's 1, but it's 2. It's usually in the back, but when they make the problem, sometimes they'll put it in the front just to add some confusion. Okay, let me locate HK, 0, 2. Up in amplitude, down in amplitude, and then over by 1 period. So I have that same situation. I need to change my scale or get a different graph paper. So let's see, I'm going to go by 2, so I'm going to make it 1, 2, 3. See, back to my starting position, HK, up in amplitude, down in amplitude, and over by 3. 1, 2, 3. And then I want to cut it in half and quarters. Upside down sign still starts in the middle, but in this case it's going to go bottom, middle. I'll check it again. So I'm gonna stick with the peaks. And that's kind of a pain. I don't want to calculate. I guess I see that's about 2 1/4, but I don't trust it. I think this one I feel safer. Even that's tricky, but it's like 3/4 to me. So I'll plug in 3/4 into this equation. 3 times 3/4. Cancel, I get pi over 2, which is there on the unit circle. Since sine is y, cosine is x, sine is 1. So I get this whole thing turns into 1. -1 plus 2 is 1. Okay, so that works. If I want to be, so that makes me like 95% sure I'm correct. But if I want to make 100% sure, I would plug in another point. So I have to be careful. This would be a mistake. You have to, kind of like that last one, you have to do a little bit of work to get it into the actual correct format. In this case, you have to factor out 6. Which means h is negative pi over 6. And the period 2 pi over 6. A very small period, pi over 3, where would that even be? Somewhere in here. So that's pretty tricky. Pi over 3s and pi over 2s don't go together that well. Like pi over 4, sure. Even pi over 8. Pi over 3. So I would likely change the scale for this one also. This is a tricky part. So I'm choosing the scale. And a couple of things are going to have to be on my x-axis scale. Pi over 6 and pi over 3 both need to be convenient to graph on this. But also my quarter period intervals. So what I'm going to do in this case, since I'm concerned I want to get the scale right, I want to make it easy as possible. And I'll do that by planning it out now rather than just picking a point and saying, oh, that's pi over 3, and then from that trying to figure out where pi over 6 goes. That makes it harder. So I'm going to do some careful planning. First thing I'm going to do is calculate what the quarter period would be. So I'll take this and I'll divide it by 4, or multiply it by 1/4. And it's pi over 12. That's I'm sorry, it's the quarter period. So I want to make sure that's included in my scale, whatever I choose. First technique. Second technique would be to get all these in common denominators. They're hard to relate to each other right now. I don't know which one's bigger. I guess, okay, you can tell which one's bigger, but let's just get them into the same denominator. So my period, the common denominator between 6, 3, and 12 is 12. So let me just get this into 12ths. 4 pi over 12. What about this one? It's going to be negative 2 pi over 12. Okay. All right, so now I'm going to choose my scale, mostly based on the period, this new period with that denominator, and h. And I'm mostly looking at just the 2 and the 4. So I'm going to choose block sizes of pi over 12. So this will represent 2 blocks. This will be 4 blocks in the positive direction. All right. Is that a good choice? I think it is. All right. So that's going to make this 2 blocks. Pi over 12, negative 2 pi over 12. All right, that is my HK. And then I'm going to go to the right, 4 pi over 12. 1, 2, 3, 4, but that's not correct. So I need to start from my HK and then go 4 blocks to the right. That's how I map out a period. I start from the left side. All right, 1, 2, 3, 4 pi over 12, which is actually 2 pi over 12 in my scale. This distance is 4 pi over 12. All right, let me go up in amplitude, down in amplitude on my box. And cut it in half and then cut it in quarters. All right, so upside down sine. Sine starts in the middle, goes high normally, but it's upside down. All right, since this was a tough one, complicated, I am going to check this one. So I'm going to do this peak pi over 12 and plug it in there. And this would be 2 pi over 12. So I get 3 pi over 12. 6 times 3 pi over 12, which is 3 pi over 2. Negative 3 sine 3 pi over 2. 3 pi over 2 is down there. And since sine is that y coordinate, it's negative 1. So negative 3 times negative 1 was positive 3. Okay, so that checks out. Before I move on, I just wanted to mention again, it's kind of messy in here, but the key point was use common denominators to make your fractions easier. Even this scale is not using common denominators. In all of our problems, the scale hasn't had common denominators. They're easy enough fractions where we're familiar with them. We don't desperately need common denominators. But just as an example, how much easier it would look if we did use common denominators. This would be 2 pi over 2, and this would be 4 pi over 2. If you have common denominators, the numerators will be more obviously sequential, 1, 2, 3, 4. So that's why that's helpful. The last problem and this problem, these are the hardest type, the ones that have a period change and a horizontal change, a shift. Those are the hard ones. Because these things, they affect each other. And they have the complicated fractions. All right, let's do this one. It's not in the right form again. Factor out the pi. Even that's a little tricky. Half. Let me double check that. If I distribute the pi back in, yeah, it turns to pi over x. Pi times 1/2 is pi over 2. Okay, that factoring must be correct. So it looks like, again, I'm going to have to change my scale. Guess these numbers aren't so large. They're not so weird. But it's not that critical. It's not that difficult to choose a scale. Let's see. I guess I'm about to make a mistake. Oh, not really. So I guess there's already a 2 there. I could choose that to be 2. This one. I'm going to choose this one, this one. For no particular reason. You notice I didn't do the quarter period in this case. I could, though. It'd be 1/2. -1/2, -1. That'll be my HK. Up in amplitude, down in amplitude. 1, 2, 3, 4. I'm off the grid. I think I'll just go with it. I could change the scale on the y-axis too. But I've already drawn this point, so maybe I'm just going to go off the grid. Okay. And then right by 1 period. So I'm not going to go all the way to 2, remember, because I'm starting at 1/2. Let me count carefully. 1 and 2. This will be the end of my period. I'll draw my box. And halves and quarters. So I've got a positive cosine, starts high, goes middle, low, middle, high. It's a hard one, so I'll check a point. I'll check this point right here, 1.5 or 3/2 on a 4. Put that in. Goes 3/2 pi plus pi over 2. Is that 5? 4 pi over 2. 2 pi. Again, whenever you plug in these numbers, it'll always turn into 0 or pi over 2 or 3 pi over 2, one of those axes. It's on the unit circle. That's why it's not that hard to check your answers. You always get easy cosine values. Cosine of 2 pi is right there, and since cosine's that x, this is all 1. 4. Okay, it checks out.